Hello, everybody. Welcome to lesson number 28. This is our lesson all about circles. We are going to talk about parts of a circle and how to work with angles within the circle. So first, let's talk about parts of a circle. In the middle there, we have our center. This is our O, our center, the middle point of the circle. Radius is a line from the center to the edge. So a center to the edge. This is our radius, the center to the edge, half of the diameter, because the diameter is a line that goes across the whole circle through the middle. So this whole thing is our diameter. Half of this is our radius. Now, a rule here, our diameter is our radius times 2. Our radius doubled is the diameter. For example, there, if a radius is 5, the diameter will be 5 times 2, which will be 10, and the diameter would be 10. The circumference, which we are familiar with from a previous lesson, is the distance all the way around the circle. So our circumference is like the perimeter. This is our circumference all the way around. A chord is a line connecting 2 points on a circle. This is a chord. Now, a fact is that the diameter is the longest chord in the circle. The diameter will be the longest line connecting 2 points in a circle. Now we have some theorems, some notes, just different things about circles. There's something called equal chords theorem. If 2 chords, so if there's 2 lines from the center to the edge that are the same length and they are the same distance from the center, so these will be the same. So if one is 4 centimeters, the other one will be 4 centimeters. An arc is a curved part of the circle between 2 points. You have 2 points, and that little curved area in between the 2 points, that little curve, is the arc. If a pair of arcs in the same circle are congruent, their inscribed angles are equal. Now, that whole sentence, you can just put on pause because we are going to be working with angles soon. And a tangent. So a tangent is a line that touches the circle at one point. So if you see the diagram there, there's a line that touches the circle at exactly one point right here. That's the point of tangency. So there's a theorem here called the radius tangent theorem. Here we have our radius. Here we have our tangent. And those lines will be perpendicular to each other, which means they will have an angle of 90 degrees. That is it right there. So this will be 90 degrees. Here's when we start talking about angles. So there's 2 angles we're going to be talking about, an inscribed angle and a central angle. So if you look here, this is our circle. Here's our center, that black dot. The inscribed angle is this top angle, this one at the top. That's our inscribed angle. That's just what it's called. Here at the circle, the black dot, because that black dot is our center, that angle there is called our center angle. So this is our center. That is called our central angle. Down here, our central angle is an angle at the center of the circle, and our inscribed angle is an angle at the edge of the circle. Now, the measure of the central angle is twice the measure of an inscribed angle. So the central angle will be twice, 2 times the inscribed angle above it. So central angle here equals 2 times the inscribed angle at the edge. To find this inscribed angle at the top, we just have to do the reverse function. So it would be inscribed angle equals the central angle divided by 2 to find what this top angle would be. And now here, angles in a semicircle, if you notice, if a triangle is drawn inside this semicircle at the top, there will always be a 90 degrees right here. Triangle, a key idea, the triangle in a semicircle will always have a right angle. So it will always be a right triangle. Now we can practice. So solve for the missing angles. Here it's asking us to find x. So we know this is 90. We know this is a triangle. All the angles in a triangle should equal 180. We can do 180 minus what we know to find x. Minus the 31 we're given, minus the 90 that we know. So we're going to use our little sentence. Therefore, our 3 dots, x is 59 degrees. Below, very similar idea. We're going to do the exact same thing again. A, this angle here, A, is 180 minus 90 minus 54. Therefore, A is 36. 36 degrees. Okay. Now here we start using our center angle, our central angle, and our inscribed angle. This is our central angle. This is our inscribed angle. Inscribed angle and central angle. So we know the central angle is 2 times the inscribed angle. So for A, finding x, we will need to divide the center angle in half, divide it by 2. So that gives us 35. So therefore, x is 35 degrees. And 35 times 2 gives us 70. So we know we did our math correctly. Here, y, we know the central angle is 2 times the inscribed angle. So we need to multiply our inscribed angle at the top, 18, by 2. And that will give us our central angle. So this is, and then we're going to, therefore, y is 36 degrees. Now we're looking at angles in a semicircle. The inscribed angles in a semicircle subtended by a semicircle are right angles. So this triangle here will have this right angle. Now we need to solve for x. So we know all the angles in here should equal 180 degrees. So now we will take x equals 180 degrees, take away what we know. Take away what we now know. That gives us a balance of 30 degrees. So x will be 30 degrees. Therefore, x equals 30 degrees. 90 plus 60 plus 30 will give us 180. Therefore, we could check our math and know we did that correctly. Very similarly here, because this triangle, this is where it's touching the circle. This we know is a right angle, 90 degrees. So because we know that's 90, we know x will be 180, take away 70, take away 90. That leaves us with 20 degrees. So x will be 20 degrees. Therefore, x is 20 degrees. Now we have angles on the same arc. So if a pair of arcs in the same circle are congruent, their inscribed angles are equal. Sounds a little complicated, but if you see here, this is an arc. Let's choose these 2 points, point and a point. This is the same arc. You have 2 angles on this arc. If 2 angles are on the same arc, the angles will be equal. You notice they are the same. So now down here, we have this arc. We have 2 angles. The angles are the same. That's what that sentence is trying to explain to us. Knowing all these angle rules, we can find this. So this is 45. So knowing that this is on the same arc as this, we know this is 45. Therefore, x is 45. And that's it. That's all you would write. Here, you would know you cut the circle in half. These 2 angles are on the same arc. So that means that x would be 53. Because you know they would be the same. Now over here, it's asking for x and y. So we need to start by finding something. We need to find x or y first. So if we look at this circle, you can see, again, split this in half, x would be the same as 50 because it's on the same arc. They're the same angles. So we know x is 50. Knowing x is 50, we can solve for y because now we can just use our triangle there. Y will be 180 take away 50 take away 92. And that'll give us 38. So the y will be 38 degrees. So therefore, x is 50 degrees and y is 38 degrees. And that completes our lessons on circles. You can complete your student handout, and I will see you next time.